Hello and welcome to Chapter 5, Section 6. This is all about the slope and rates of change. So now we're taking all of our linear functions, now that we know how to graph a line, and we're going to look at some of the ways we can manipulate those lines or understand those lines better. And one of the ways that we understand it better is to understand the slope of the line. The slope is how steep it is. It's a measure of steepness. Now we find the slope. The slope is identified mathematically as rise over run. It's the vertical change, or the change in y, over the horizontal change, or the change in x. Now remember, horizontal is the flat one because you're looking at the horizon, and vertical is up and down. For example, if you were to stop here looking at this graph, where the slope is identified as when you find a very specific point on the line, and here it's crossing the x-axis right here, so this is a point. Finding the slope tells you how much does it go up and over until you can find another point on the line. Because there are a lot of points on the line that are in between, so you want to find an exact point. So here we have a point that is -3, 0, and this point is 0, 2. So when we go from this point to this point, what is the rise over run? Well, it goes up 2, rise, and over 1, 2, 3. So it has a slope of 2/3. And if it ended up being like 4/6 or something, of course you would reduce it, but you always want to reduce it to whole numbers. So this has a slope of 2/3. Whereas this one, here we have a point at 0, 2, and this point is 2, 0. This is going to go down 2 and over 2. Down 2 is going to be a negative rise and over 2. So this is a slope of -2 over 2, and we're going to simplify that to -1. It's really -1 over 1, but we don't care. So this is a slope of -1. Now, if you wanted to go this way, if you knew that this point was, what is that point? That is -2, 4. Then this is going to go up 2 and backwards 2. Now look what that does. That still gives a -2 divided by 2 is -1. 2 divided by -2 is -1. Doesn't matter if you put the negative sign on the top or on the bottom, that's still going to make your answer negative. The only difference is if there's a negative on the top and a negative on the bottom, that makes your answer positive. Does that make sense? That's the division rules. That would be -2 divided by -2, that would be a positive one. But if you only have one negative, your answer is negative. But these slopes are the same, no matter if you put the negative on the bottom or on the top. Okay? This is a positive slope. This is a negative slope, because rise over run here happens in the positive direction. Rise over run here, rise over run here happens in the negative direction. Positive slopes go this way, negative slopes go that way. Always. Okay? Now, some things to keep in mind are lines that don't have a slope. Okay? When you have a line that's completely vertical, that means one of these is 0 and one of these is undefined, and I need you to understand why rather than just memorize which is which. Okay? Your change in y here, all the y's are changing. And your change in x is nothing. All of the x's are the same, there is no change. Whereas here, all of the x's are changing, and y is not changing at all. Now, if you remember, when we talked about fractions, if you've got a number, if you've got 4 over 0 versus 0 over 4, one of these answers is 0 and one of these answers is undefined. If you have something and you break it up into 4 categories, and you're talking about 0 of them, that's 0. If you break something into 4 categories, but you're talking about 0, let's say I've got a pizza, and each of these pizzas has toppings that are different colors. And which piece is blue? How much of this pizza is blue? Well, 0 out of 4 pieces are blue. So I'm still talking about 0. This is a number. This equals 0. However, this means I have broken this pizza up into 0 pieces. You can't do that. That doesn't make sense. This answer is considered undefined. So this line has a slope that is undefined, whereas this has a slope of 0. Just so you know the difference, okay? Moving on. Now, how can we use this slope to help us graph the line? Now, sometimes when we have graphed a line, we've needed to be able to understand 2 points. What if we only know 1 point, but we also know the slope? We can actually get from a point to the next point on the line if we know the slope. For example, this is our slope. We have a slope of -3 over 4, and we have a point that is -3, 2. So we're going to start at our point, -3 and up 2. We're going to start there, and we're going to have our slope. Now, our slope says we're going to go down 3 and over 4. So we're going to go down 3 and over 4. And there is our next point on our line. And we can draw our line this way. Let's try it again. Here's our slope and our point. So our point is -1. Oh, look, we have our point. And our slope is -2. Now, if we need our slope to be a fraction, so anytime our slope is a whole number, we're just going to put it over 1. We're going to make it a fraction. So here we have a slope of -2 over 1. So we're going to go down 2 and over 1. And there's our next line, or our next point. So this line goes in this direction. I'd like you to note that both of these have negative slopes, and both of them point in this direction as opposed to pointing in this direction. Okay? So, now it's your turn. Here's a graph. Please draw yourself a basic graph really quick, and I would like you to try it. Start at your point and work your slope and see if you can draw a line. Please push pause and give this a try. Okay? All right. -1, -2, and we go up 3 and over 1, and there's our first line. -1, -1, and we go up 1 and over 2, and there's our second line. And notice these both go in the positive direction. How'd you do? Now, what does this look like in a word problem? The graph shows, and here they've drawn you a graph, the graph shows the distance a trout swims over time. Is it a constant or a variable speed, and how fast does he swim? So, here's something I haven't explained yet. Constant versus variable speed. If you were going the same speed, do you remember when we did Chapter 5, Section 2, Interpreting Graphs? That showed you that if they're going at a constant speed, that's going to be a straight line. A variable speed, that's going to get graphed like, sometimes he goes fast and sometimes he goes slow, that kind of thing. Okay? But a constant speed is a straight line. So constant versus variable is a really easy thing to see in graphs. If it's got any curve to it, it's varying. So, but it does ask you, is it a constant or a variable speed? And they'll show you some graphs that are curved and some graphs with straight lines. So now you know the difference, okay? And then the question is, how fast does he swim? This is the real math question here. You're going to find the slope in a fraction form, and you're going to find the rate. Now, if you remember, if I can eat 12 cookies in 3 minutes, you want to find my rate of cookie consumption. You want to be able to say how many cookies can she eat per minute. So you have to put it over 1. So if you end up with a fraction 12 over 3, you want that to be a 1. So you're going to divide the top and the bottom by the denominator so that you can get 4 cookies per minute. Okay? So our rate is going to be, find the slope and put it over 1. So here we have our graph. And these are distances in miles in increments of 10. And then these are hours. Our time is in hours in increments of 30 minutes. How fast does he swim? Well, we know one point on our graph is 4, 60. The other point on our graph is 0, 0. So if we get from 0, 0 to 4, 60, we're going to count rise over run. How much does it go up from 0? And this is easy to tell. From 0 to, it goes up 60, and it goes across 4. So how fast does he swim? Well, he swims 60 miles in 4 hours, but I want a miles per 1 hour. So I'm going to reduce both of these by 4, and I'm going to get 15 miles per hour. Again, it's being able to read the words, understand what it's asking, how fast does he swim is the rate, and knowing that that means rise over run, and run has to be 1. Okay? So, now it's your turn. Here's some practice for you. Number 1, how fast does the monarch butterfly fly? And here you're going to round to the nearest tenth of a mile per hour. So you start at 0, and you're going to end up with, after 3 hours, he flies 70 miles. So you're going to write that slope going from 0, 0 to 370. Write the slope, which is rise over run, and reduce it to find the rate. Number 2, the first question is this a positive or a negative slope? And here's the line for question 2, and here's the line for question 3. Is it a positive slope or a negative slope? And then you're going to actually find the slope. So you're going to find a point, and you're going to count rise over run to the next point. So on line 2, you have 2 points. You have -1, -1. And you have 0, -4. On line 3, you have 2 points. You have 1, 2, and you have 5, 4. All right? Then you're going to take these 2, and you're going to graph these. This has a slope of -1, and you're going to start at the point -1, 4. This has a slope of 3/5, and you're going to start at the point 3, -1. Okay? Put this all together. Make sure there's a cloud around your turn. Put any hazard signs where you have any questions. Come back to class with questions so that we can be really strong in this, because I think this is the fun part of math. So good luck, and I'll see you tomorrow. Take care.